Scenario 1. Kate is a coder. She has already written source code for her mobile app ChitChat. Her code is working fine. Users of her app can send text messages to each other perfectly. No bug at all, everything is just working great for all. Scenario 2. Suddenly Kate decides to add video calling functionality to her app and starts writing all the source code. She just adds and updates her existing code without using any source code management tool. Finally, a brand new version of app is launched. Scenario 3. Users install new version of app and start using the app's new video calling feat. After 2 to 3 days, Kate starts receiving complaints that the app is crashing while video calling, and also text messaging not working. Scenario 4. As Kate did not use any source code management tool, it takes 2 weeks for Kate to manually find out the bugs and restore the text messaging only, and 2 more weeks to resolve video calling crash issue. As app had a bug, its 90% users switched to another provider's app fast chat, as those users did not wait for Kate's app. If Kate would have used any source code management tool or software, it would have taken a couple of minutes to resolve the issues, and her app's users would not wait for 4 weeks, as these tools track all the changes in the source code files. Source code management, SCM, also known as version control, is used to track modifications to a source code repository. SCM tracks a running history of changes to a code base and helps resolve conflicts when merging updates from multiple contributors. SCM is also synonymous Version control is a system that records changes to a file or set of files over time, so that you can recall specific versions later. A version control system, VCS, is a very wise thing to use. It allows you to revert selected files back to a previous state, revert the entire project back to a previous state, compare changes over time, see who last modified something that might be causing a problem, who introduced an issue, and when, and more. Using a VCS also generally means that if you screw things up or lose files, you can easily recover. In addition, you get all this for very little overhead. Generally, we have divided the version control system in 3 categories. That is, local, distributed, centralized version control systems. Many people's version control method of choice is to copy files into another directory, perhaps a timestamped directory, if they're clever. This approach is very common because it is so simple, but it is also incredibly error-prone. It is easy to forget which directory you're in and accidentally write to the wrong file or copy over file. To deal with this issue, programmers long ago developed local VCS that had a simple database that kept all the changes to files under revision control. These version control systems are local to a computer, so they carry a higher risk of data loss, and it is not possible to collaborate on the same project by many people at the same time. The next major issue that people encounter is that on bigger projects, they need to collaborate with developers on other systems. To deal with this problem, centralized version control systems, CVCS, were developed. These systems have a single server that contains all the version files and a number of clients that check out files from that central place. For many years, this has been the standard for version control. This setup offers many advantages, especially over local VCS. For example, everyone knows to a certain degree what everyone else on the project is doing. Administrators have fine-grained control over who can do what, and it's far easier to administer a central version control systems. than it is to deal with local databases. However, this setup also has some serious demerits. The most obvious is the single point of failure that the centralized server represents. If that server goes down for an hour, then during that hour nobody can collaborate at all or save files version changes to anything they're working on. If the hard disk, the central database, becomes corrupted or dead, and there are no proper backups, you lose absolutely everything, the entire history of the project, except whatever single snapshots people happen to have on their local machines. Local VCS also suffer from this problem. Whenever you have the entire history of the project in a single place, you risk losing everything. This is where distributed version control systems step in. Clients not only just check out the latest snapshot of the files, they also fully mirror the repository, including its full history. Thus, if any server dies or corrupts, and these systems were collaborating via that server, any of the client repositories can be copied back up to the server to restore it. Every clone is really a full backup. Many of these systems deal pretty well with having several remote repositories they can work with, so you can collaborate with different groups of people and teams in different ways simultaneously within the same project. This allows you to set up several types of workflows that aren't possible in centralized version control. Git is a distributed version control system. Git is fast. Nearly all operations are performed locally, giving it a huge speed advantage on centralized systems that constantly have to communicate. Git stores its data more like a series of snapshots of a small file system. With Git, every time you commit or save the state of your project, Git basically takes a picture of what all your files look like at that moment in time and stores a reference to that snapshot. To be efficient, if files have not changed, Git doesn't store the file again, just to link a reference to the previous identical file it has already stored. With few commands you can revert your project to any only main thing to remember about Git if you want the rest of your learning process to go smoothly and very easy. Git has three main states that your files can reside in: modified, staged, and committed. Modified means that you have changed the file, but have not committed or saved it to your database yet. Staged means that you have marked a modified file in its current version to go into your next commit snapshot. Once a file is in staged area, it can be tracked by Git, and changes can be committed or stored to Git database that resides in. Committed means that the data is safely stored in your local database. The working tree is a single checkout of one version of the project. These files are pulled out of the compressed database in the Git directory and placed on disk for you to use or modify. The staging area is a file, generally contained in your Git directory. This file is also called the index file. The Git directory is where Git stores the metadata and object database for your project. This is the most important part of Git, and it is what is copied when you clone a repository from another computer. We end here our part 1 source code management. In next part, we will more focus on Git basics. Thank you. I am Emma from Sytems Dev. Please subscribe for next part if you still have not subscribed yet. Press the icon bell for more updates.